Everyone, and welcome back to Brains Are Beautiful. In this episode, we're going to be talking about fractions. And maybe you think you're the expert on fractions already because we've been doing them since, oh my gosh, maybe elementary school. But as with everything in algebra, fractions get complicated really fast. So let's get started. I'm just going to do mostly examples. As you know from all my other videos, I love examples, and I think they're the most helpful thing that somebody can show you. So let's say we have the fraction 5/6 minus 3/6. And in this video, we're just going to go over adding and subtracting fractions. And it's not just going to be as simple as this, but I'm going to start off with a really simple basic example, so that way I can compare algebra to it. So 5/6 minus 3/6, we all know gives us 2/6. And we know that because we know the denominator stays the same, and the numerator you just subtract. And we know we can then further simplify this, of course, to 1/3. And along similar lines with adding, we can say 2/5 plus 1/5 equals 3/5. So, and then if we were to put this in terms of just variables, we could literally say that a over c plus b over c equals a plus b over c, and for subtraction, a over c minus b over c equals a minus b all over c. So that's kind of our rules of thumb. So taking this a step further, let's say that the problem asked you to combine these three fractions, and the fractions were m over x plus 3, 2 plus 2n over x plus 3, and minus n over x plus 3. So we're just going to stick with the same rules we used just a couple minutes ago, and since we have all common denominators, we don't have to worry about doing anything to them. So we can literally just say the whole thing is x over x plus 3, and then we just add these together. So we only have one m, and then we have plus 2n minus n, and simplifying this further, we get m plus n over x plus 3. Not too bad, right? All right, let's do a slightly harder example. And this one is going to say, what if we don't have equal denominators? In other words, what if we have different things in the bottom of the fraction? We can't just add straight across the board like we have been doing. So I'm going to start off with a simple example because you guys actually already know how to do this. If you have 11 over 12 minus 3 over 4, and you want to combine these fractions, what you're going to do is you're actually looking for the LCD, the least common denominator. And you guys know from past experience how we do this is 4 is actually a factor of 12, and so we can multiply this entire right fraction by 3 over 3 to get the same denominator. And that's going to give us, just writing out all the steps, 11 over 12 minus 3 times 3 is 9 over 12. And of course that simplifies to 2 over 12, which further simplifies to 1/6. Okay, so we can apply the exact same thing to our Algebra 1. So maybe we're given the problem 2x minus 7 over 6x plus 1, and we're going to add to it x plus minus 3 all over x plus 4. So we can't just add like we did earlier because, see, these bottom denominators are different, and so we wouldn't be combining the same things. So what we're going to do is we're going to find the LCD, just like we just did for the fractions. And so the LCD for this is pretty straightforward. You're just going to multiply the two denominators together. So the LCD is going to be 6x plus 1 times x plus 4. And this is our LCD, least common denominator. And so then to solve the equation, you're going to take the first fraction, 2x minus 7 all over 6x plus 1, and you can multiply things by this fraction as long as you're multiplying by a 1. And so to multiply by a 1, what the bottom is missing is the x plus 4. So we can multiply by x plus 4 over x plus 4, because we know that that really is just 1 over 1 but it's going to change our fraction, thankfully, which is what we want. We then want to add the next fraction, so x minus 3 over x plus 4. And what is missing in our denominator in this fraction? Well, in this fraction, we're missing the 6x plus 1. And so we're just going to multiply by 6x plus 1 over 6x plus 1, which you can then see again is 1 over 1. So, further simplifying this, we now know that our bottom of our fraction has the same denominator. So we can just write that out. So we have 6x plus 1, and we have x plus 4 multiplying each other. That is our LCD, or our denominator. And so then what we can do is we can just write all the terms out. So we have 2x minus 7 and times x plus 4. And then we're adding to it x minus 3 times 6x plus 1. All right, so now this is where your FOIL comes into play. If you can't remember how to FOIL, go check out my other videos. There is a FOIL video right there that walks you through lots of examples on how to FOIL. And so just if you need a quick reminder, FOIL is just first, outside, inside, last. And so we're doing that to each term. First, outside, inside, last, and then we're going to do it again over here. First, outside, inside, last. So to do this, we're going to end up with 2x squared plus 8x minus 7x minus 28 plus x times 6x is 6x squared. X plus times 1 is x. Negative 3 times 6x is negative 18x. And negative 3 times positive 1 is negative 3. And that's all over our LCD, which is 6x plus 1 and x plus 4. So now, this is actually the answer to our problem, but there is no way your algebra teacher is probably going to accept this. We need to simplify this down further. So that means we need to combine all the squared terms, all the x terms, and all the constants together. So to do this, let's just look for all the common terms we have. So in this I see we have a 2x squared and we have a 6x squared, and that's it for our x squared terms. So 2x squared plus 6x squared is 8x squared. Okay, so next we're looking for our just single x terms. So we have an 8x, we have a negative 7x, we have a regular x, and we have a negative 18x. So let's combine all those. So 8x minus 7x is going to be negative 1x, plus an x, positive 1x, plus an x is going to be a 2x, and minus 18x is going to give us a negative 16x. So minus 16x. If you need to write that out, of course, by all means, write that out. And then for our constant terms, we have a negative 28 and a negative 3, which when you add those two together, you're going to get a negative 31. And that's all going to be over 6x plus 1 and x plus 4. And that is the answer to our example. Now, maybe in like some of your homework problems, you might get a numerator that will factor. Such as if I'm thinking about one, x squared, let's do plus 10x plus 25. If you get that for your numerator, then you would further simplify the numerator to x plus 5, and that could be squared, or you can write x plus 5 again. Okay, and then that would obviously be over your denominator. But for a specific example right here, that's as simple as we can make it, and so that is our answer. Thanks everyone for watching, and please leave questions, concerns, or comments below if you need more examples or want some more explanations to any of the problems. Just go ahead and leave it in the comments. Thanks guys for watching, and remember, brains are beautiful.